Hello and welcome to MATLAB course. This is Salim. In this video I'm going to talk about the for loop in MATLAB. Imagine you have a code and there is a part in that code you need to repeat several times. You have two options to do that. The first one is the for loop and the second one is while loop. In this video I'm going to talk about the for loop. Let's start. So first of all, the structure of the for loop is like that. So we have here for and we have end. And between for and end, this part will be executed or repeated several times. This is the part which we are going to do several iterations. And if you check here, you will find I equal the start value, colon, spacing, and then colon, and then the last value. What is I first? The I is called index. And this index is just a letter. So it can be any letter, A, B, C, D, any letter from A to Z. But the most common is, as I wrote here, I, J, K, M, and N. This is kind of the most common among the programming language. And the most important part is the I value or the index value will change every time with the iteration. So how this value will change? So the first value for I will be the start. And every time this I will increase by the spacing till reach the last value. For example, if we write I equal from 1 to with the step 1, 2, 3. So I in the first value will be 1. And then will increase every time by this spacing, which is 1, so it will be 2, and then increasing by the spacing will be 3. The last value will be this last value. Once the I reach the last value, this iteration will stop. So the I value will change every time with each iteration as follows. For example, in the first iteration, so this is kind of the first time we are going in that iteration, the I value will be the start value. And then the lines between for and end will be executed. And then the code will go back to the for to change the I value. In the next iteration or the second iteration, the I value will change from the previous one was the start. It will change to be the start plus the spacing. So it will increase the new I, it will equal the old I plus the spacing. And because the I from the previous was the start, so it will be start plus the spacing. And then the lines between the for and end will continue, will execute it, and then go back to the for loop to change the I value. So this means that in every iteration, the I value will be changing or increasing by the value of the spacing. And this process will continue until we reach the last station or the last iteration in which the I value will equal the last value. In that sense, the I value will be last, and then we will execute all the line between the for and the end and go to end and then finish the loop and then continue the code. So we will not go back every time. To understand that, let's take example. So for the following three examples, trace this program to know what will be the output from this program. Let's start with the first one. So in the first one, we wrote for k, so we change here the index from I to k. Any letter is okay. So for k equal from 1 colon with 1 colon to 5. So the start is 1, the spacing is 1, the end is 5. And between for and end, we need every time to display the value of k. So we will check the value of k and print it out. So let's do that by our hand. So in the first iteration, the k value will equal to 1. And then display k, so the first output will be 1. And then we will go to the second iteration. So the k value will increase by the spacing, so it will be 2. Display 2, so the output will be 2. And then go to the next iteration. So the k value will increase by the spacing, it will be 3. So we will print 3. And then go to again to the k. So k will increase by 1, it will be 4. And display k, it will be 4. And then go to the next iteration. So the k will increase by 1, it will be 5. This is the last value. So in this time, we are going to display k, which is 5, and end and finish. So we will not continue. So if we just show the output, so the output from the code, it will be 1, 2, 3, 4, 5. Okay, let's check the next code. In the next code, we said that for I equal to from 1 with spacing 2 to the end 9, and every time print the index I. So the first value of I will be 1, and display I, it will be 1, and then do the first rotation, and then I will increase by 2, it will be 3, so print 3, and then go the for loop, and increasing 2, it will be 5, and then print 5, and then go to the next loop, and then add 2, the 5 will be 7, and print 7, it will be here, and then do the for loops, and then increase this index by 2, it will be 9. This is the last one. So we will display 9, and then go to end and finish, and then continue if we have other lines. So the output from that code should be 1, 3, 5, 7, and 9. And please check that this spacing, it can be not only 1, but any other number. But if we check this code, the third code, so this for j equal to 9 to minus 2 to 1. So the spacing here in this time is negative. So we decrease from the start to the end. No problem for that. This is similar to when we take that class about the array creation. And in array creation, one of the methods was using the colon. And this is very same colon to increase or decrease or have a range of number. So let's trace this program. In this program, the first value of j will be 9. So display j, so the output will be 9. And then go to the first iteration and then decrease the 9 or the previous j by minus 2, so it will be 7. And display j, it will be 7. And then go to next iteration, so the 7 will decrease by 5, so display 5, and then go to the next iteration, and then decrease by 2, it will be 3, and display 3, because we have display 3, and rotation, and then decrease this to 1. And 1 is the last value here, so it will display the 1, and then go to end and continue without doing further loop. So the output from that code will be 9, 7, 5, 3, and 1. And one of the notes about the for loop, if you don't define the spacing, so if we doesn't write the spacing here, the spacing will be 1. So we already know that about the array creation again. So for example, if we try to trace the program, for example, we said that for m equal minus 1 to 2. So this is the start and this is the end, and we didn't define kind of what is the spacing between. And every time we need to display m. So it is very easy. The first value for m, it will be minus 1, and the spacing, the default will be 1. So display m, which is display minus 1. And then go to the first loop and increasing by 1. So minus 1 plus 1, it will be 0. And then display m, it will be 0. And go to the second loop and then increasing the m by 1, it will be 1. So display m, it will be 1. And then go to the next loop and then add 1, it will be 2. And 2 is the last value here. So this is the last iteration. So display m, it will be display 2, and then go to end and continue if we have something. So the output from that code, it will be minus 1, 0, 1, and 2. So until now, we learned that the spacing could be 1 or any positive value or even negative value, or we can remove the spacing and it will be the default is 1. So to know how many loops or iteration the for loop will do that, it is very easy. So because we know the start, the spacing, and the last, so the number of iteration is equal to last minus the start dividing by the spacing plus 1. Let's consider the following example. For example, trace the following code, estimate the number of loops, and what do you think about I1? So for example, I1, the initial value is 0. And for n, this is the for loop. And for n equal from 1 with step 2 to 9, so the n first value, it is 1. And then start the first iteration. And in the first iteration, they said I1 equal I1 plus 1, so I1 will increase every time by 1. And then return back, n will increase, so n will be 3, and then go to the second iteration, so I will increase 1, it will be 2, and then for loop, and then n will increase, so the n, it will be 5, and then go to the third iteration, so I will increase, it will be 3, and then go back, and then increase the n, it will be 7, so, and go back, go down with I, so I will increase to 4, and then rotate back, and then the n will increase, so n will be 9, and this is the last value, so it will be the last iteration, so it will go down, so down I will increase 1, it will be 5, and then this is the end. Count how many times did we do the iteration? 1, 2, 3, 4, 5. We go down 5 times. So we repeat this part 5 times. And the I here is equal to 5. So I here is kind of the counter for that code. It counted how many times did we loop here. So if we display I1, so the output for I1, it will be 5. And this function repeated 5 times. And the I1 is kind of the counter. It counts how many loops or how many iterations this code we have. So usually this is very common trend. If you need to loop or to count how many iterations do you have, you can do something like that. Define the start value is equal to 0 and every time increase by 1. This is kind of counter for your code. This is a time for your practice, and this example is kind of what we are going to use, mainly the for loop or doing loop with the array or with matrix. Because we usually need to do some process for the matrix element. If we have several elements, sometimes we need to change, we need to update, we need to check. So this is very important example. So the question says that we are a vector named A has the following value. This A has 3, 4, 2, 1, 6, 4, 5, and these are 7 values. And we need to estimate the summation of A element. So we need to say 3 plus 4 plus 2 plus 1 plus 6 plus 4 plus 5. We need to know how is the summation of the vector element. But we need to use the for loop. So we need to check every element every time, and we need to re-estimate the summation of A element without using for loop. We need to use function. We already learned about that. Let's go to our live script to check how to do that, but please pause the video first and try to think how we are going to do that. And this is kind of our MATLAB, and in MATLAB, we are going to open the live script I have. So I will click open, and then I will go to the place where the live script is. This is the live script I have, which having the example. We don't need the command window. I will minimize, and we don't need the workspace. I will minimize. And here you can find the previous codes. For example, trace the output of that code. If we just run the section, we will have here from 1 to 5 with a spacing 1, it will be 1, 2, 3, 4, 5. And for the second code, if we write 4i from 1 with increasing 2 to 9, if we just run the code here, we will have the output. Run the section. we will have 1, 3, 5, 7, 9. And the third example, when we started with a negative, like the spacing, from 9 to 1 was -2. If we just run the code, we will have here, just click and then run, we will have 9, 7, 5, 3, 1. And for this code, when we just say that we can remove the spacing, we don't mention, so the spacing will be 1, and we increase from -1 to 2. If we just run this code or this section, it will be from -1 to 2 every time, increasing like the m. And then we took that code which saying, what do you think about the I1, and trace that code and display the output. So if we just run, it will display I1, which is 5 times. If we just click here, it will be 5. And then we say that the I1 is kind of counter for the loop. Let's check this example. So this is what we say. We need to estimate the summation of the vector A, once using the for loop and the other without using the for loop. Let's check first using the for loop. So what we need to do first is we need to define A. So we are going to say A equal to, and then just write the elements 3, 4, 2, 1, 6, 4, and 5. And we can put the semicolon to suppress the output. And then let's check how many elements. We said we have 7 elements here in that. So this is 1, 2, 3, 4, 5, 6, 7. So we need to loop 7 times for this element because we need to make summation of these elements. So let me do 4, and then let me write I, which is the index, equal to start is 1, and the step is 1, and the end is 7. Of course, we can skip this middle one, which is the spacing one. And once I press enter, MATLAB automatically will write end for me. And then let's remember, when we learned from the previous lecture about how to index or how to manipulate the array, we know that every array have the value which is 3, 4, 2, 1, 6, 5, 4, 5, or they have index or the position number. So this is the first position, this is the second position, this is the third position, fourth position, fifth, sixth, and seventh. So if the I will change from 1 to 7, if we write A of I, it kind of, we check the element value every time. So let's run this code to check. If I run the code, we can find that the MATLAB print every time A of I, so I if equal 1, so A of 1, it means 3, so he prints 3. And then I will increase by 1, so every time I of 2, it means 4, so he prints 4. I of 3, it 2, he prints 2. And then I of 4, it is 1, he prints 1. I of 5, it's 6, etc. So what this happened is, we create kind of, this index could be the calling number for the element of the array A. So now we understand that if we use the index as the kind of the index for the vector A, we can repeat for every element. So we need to kind of make summation for these elements. So we can here create kind of S. This is variable to store all the value, and we will make this storage equal to 0 at first, and every time we are going to say the new S equal to the old S plus the A value. So it kind of, this element value, every time we are going there, we are going to add it to the previous summation value. So let's run this code now. So this S started with 0, and then he add to this 3, and then 3 plus 4, it is 7. And 7 plus 2, it is 9, and 9 plus 1 is 10, and 10 plus 6 is 16, 16 plus 4 is 20, 20 plus 5 is 25. So this is kind of how we make summation from for the vector element. But the second question is, how to do that without using the for loop? And we learned that also from the previous lecture about using function with array. And one of these functions was a summation. So if we use a sum of A, We will know that. Of course, we defined a here so they know, or we can copy and then paste it here and then just sum a. And let's consider this is different section. So break section and then run this section. So for this section, summation of a is 25, which is equal to 25 here. One of the common problem which may facing you now, please let me just first show you the workspace. If I click the workspace, so we have here all the variables we used before, like the a and the answer, which is like that 25 here, and I1, and this is kind of the workspace. Let me just restore that one, and let me keep it on the left side. And let me minimize that one. We are going to use shortly. One of the problems that will happen, some of the people like to make this storage name as sum. So they will change this sum and change here sum. And MATLAB say that if you need to change all this is to sum, just write shift enter. If I write shift enter, so he will change all the variable is to be sum. So this sum equals 0, and then sum equal the new sum equal the old sum plus a of I. If I just run this section, it will be the same, no problem. So we have 0, 3, 7, 9, etc. to 25. But if we try to run this section now, which is sum of a, and then run the section, it will say this is error. And the reason for that error is we use the function sum as a variable sum. So if we check our workspace now we have a variable called sum. And if we have a variable called sum, we can't use a function which called sum. So this is the error reason. So to overcome this error, we need to change the name here. For example, we can replace it as a sum underscore or just s, and then shift enter to change all the number as a sum enter, and then run all the variables. So the first thing is we change the value, but still the old variable is still defined here. So the second step is right click this sum variables and select delete. If we select delete, we will remove that variables from the workspace. They ask, are you sure? Do you want to delete? Yes. And then after that, run this section again. After run this section, this is still here rename as a sum underscore. Please remove just a sum and then run this section. And here the answer will be 25. This is the default. So the error, what happened here is if you use the function name as a variable name, this function will no longer work in MATLAB. Okay, so let's check the next example. Let me just minimize this workspace. We don't need any more. And let's check this practice. This is the final practice for the for loop. And in the for loop, like we need to display, for example, the question is display the multiply of 7 for the number interval between 0 and 30. And multiply of 7 between 0 and 70, for example, 7, and then 14, and then 21, and then 28. It's kind of multiplication of 7 between a certain interval number, and here the interval number between 0 to 30. So we need to know that we need to display or show only 7, 14, 21, and 28. So we need to display the multiplies of 7 for the numbers interval between 0 and 30 using for loop and if statement. So for example, if I just make a for loop for example, k here in this time equal to from 0 to 30, we are not going to say every time increasing by 1 and press enter and will enter automatically, and just say display k. Let's run this code to check what will happen now. So if I do that, it will kind of showing k value between 0 to 30 every time increasing by 1. So we understand that. But we only need to show the value which 7 or the multiplication of 7. And do you remember there was a function called the remainder? Remainder, it means that remainder of a value. For example, if we say the remainder, let's explain that in the PowerPoint. So let's go to the PowerPoint to have the bin, and then this is the previous example, and this is with and without using the for loops, and this is the error which explaining about if we use a sum name as a sum name. For example, here this will cause error if we try to use the sum function because we use a sum as a variable names, and how to overcome that and how to delete the variables. And this is a question about showing the 7 multiplication. And let me show the remainder value. For example, if we remember the reminder function, so the reminder function is rem, and then for example we write the value x and then another value which is y. For example, if we say remainder of, for example, 7, comma, and then 2. So what will happen for this remainder here? So it's kind of, if we divide 7 by 2, it will be something like 3.5. So it is kind of 3 times 2, and we have one step, which is one value, which is like the 0.5. So it kind of, we have 3 times multiplied to 2, which is 6. And then we will have 6 from 7, it is still 1. So the remainder of 7 divided by 2, it is 1. And what if we say the remainder of, for example, 12,5? It is this 12,5, it's kind of 12 divided by 5. The answer is 2 point something. For example, 2 divided by 5 is 2.4. And if we take this integer value, which is 2, so 2 multiplied to 5 is 10, so it kind of 2 multiplied to 5 is 10, so it's kind of 12 minus 10, the answer is 2. So the remainder of 12,5 is 2. What if I said just remainder of 14,7? So if I said 14,7, so 14 divided by 7 is equal to exactly 2. So if we say 2, it means that 2 multiplied to 7 is 14, and the original value is 14, so the subtraction is 0. So the remainder of the 14,7 is 0. And if we do the same things, remainder of, for example, 28,7, still 28 divided by 7 is 4, exactly 4. So the remainder in this case will be also 0. So we can use the remainder function to check the number between 0 to 30, and we need to display only the number, which the remainder for that, it is 0. Let's do that in MATLAB. So if we check here, and if we just check this display value, this is display for k, but what if we estimate the remainder of the value? So instead of using k, I am going to display the remainder of, for example, the k, 7. And then let's run this section. And this section are going to say 0, 1, 2, 3, 4, 5, 6, 0. This 0, it is kind of the value where 7 is. And then 1, 2, 3, 4, 0, this is 14. If we check 0, 1, 2, 3, 4, 5, 6, at 7, it say 0. And then 8, 9, 10, 11, 12, 13, 14. And 14 here, it is 0 again. So what we are going to show is, instead of display, we need to check if the number, we don't need to display all the value, we need only to display the number which the remainder equal to 0. So in that sense, we can use the if function. We can say if, and then if the remainder of k, 7 equal, and this is condition, so we should use equal sign. if the remainder of k comma 7 equal 0, in that sense, we need to display this k. Let's run this code. And now when we run this code, the answer will be 7, 14, 21, and 28. But we have one problem here, which is 0. But we don't need to show the 0. We need to exclude the 0 from this operation. So we need to put if condition here. We can say two conditions. The first one, the k, it should not be 0, and the remainder equal to 0. So we can say if the remainder equal to 0, and we need to say that k is not equal to 0. So this we have two conditions. Let me highlight it using parentheses so you can check the two conditions clearly. So the two conditions, we said that if the remainder of k comma 7 is 0, so it's apply for 0. And if the k is not equal to 0, so the k is not 0, print k. And then let's run the section. Now we excluding the 0 and only keep the number between the 7 and its multiplication between 0 and 30. That's all. Thank you. Bye-bye.